What's up, everyone? So I got these footings poured. Did that yesterday. I should be stripping them, but I'm not going to today. Hey, it's Jeremy again. Random guy stuff here. I wanted to talk about a calculator. Got mentioned in a Facebook group I was on last night, and I was told that I should probably get one, and car going by. Anyhow, and I already have one, and I love it. And I thought, you know what? I've never talked about that, so let me talk about that. It is the Construction Master 5 by Calculated Industries. Let's see if I can. The cover slipped onto the back when you're not using it. So let's see if that focuses. Calculated Industries Construction Master 5. Absolutely love this calculator. This is actually my second one. I had my first one for several years, and it got beat and abused, and to the point that the tab and batteries inside here, the tab that made contact with the battery finally broke off. So I purchased a new one. I got this one and the other one actually at Home Depot, and they run about 40 bucks, give or take. You can get them online. I looked on Amazon. Amazon has them. Here's the thing I like about this calculator versus any other calculator. I'm sure there's other calculators and other brands on the market that probably do it, but this one's just simple and straightforward, easy to use, but it calculates in feet and inches, which for a builder and a carpenter like myself, feet and inches is huge. You can also do metric conversions if you're on a metric job, which is why I originally bought my first one, because I was on a metric job. But as a carpenter, I like the feet and inch portion of it. So it's, for instance, like this footing here, we got 48 foot by 50 foot by 48 by 50. It's 196 total lineal feet. I can go 196 feet. Not sure if you've seen that. 196 feet. And I knew I wanted my vertical, get that to focus. I knew I wanted my vertical rebars every 16 inches. Now I know it's overkill, but anyway, every 16 inches on my verts. So I just divide by 16 inch, and it tells me I need 147 verts. Now keep in mind, you always need one at 0. You need one at 0, so just go plus 1 equals, and I need 148. Did I hit a wrong number there? I'm not sure. 196 lineal feet divided by 16 inches equals 147 plus 1 equals, and the 1 is for 0. Hope that makes sense. But anyhow, so I need 148 vertical bars, and so I knew exactly how many I needed. But here's something that, a function that I use with this calculator that I would have a really difficult time doing with any other calculator without knowing geometry and calculus and all that malarkey really well, which I'm not. I'm an average Joe. So this calculator helps me with it. But that's squaring a foundation. So in this instance here, I set up my batten boards and I pulled my strings. And typically you would go from corner to corner and just make those two dimensions equal, and then you know your foundation is square. But I like to double check that with the math. So in this instance, you can use the rise and run, which rise and run works great for rafters, hip and valley rafters, jack rafter, well, not jack rafter so much. You can do jack rafter calculations on this too, and I can show you that here in a second. But it also works great for squaring a foundation. So in this instance, I got a building that's 50 feet, and we'll call that rise, and then I just type in 48 feet. That's my depth. We'll call it run, and it doesn't really matter, rise and run. You're just getting two sides of a triangle, right? I don't know if you're going to draw on this plan, but you got two sides of a triangle, and so we're going to go 50 feet and 48 feet. And then you just need to get your hypotenuse, which is the distance between those 2 points, right? So to get that, just hit diagonal. 69 foot 3 3/4 of an inch. And there we have it. 69 feet 3 3/4 of an inch. And now you know what your diagonal from corner to corner is supposed to be. And math don't lie. It's more accurate than doing your diagonals, because if you make both diagonals 69 foot 3 3/4 of an inch, your dimension between that string and this string is exactly 48 feet, and between that string and that string is 40 or 50 feet in this case, and your diagonals measure what the calculator says it's supposed to measure. That building is perfect. It doesn't get no better than that. But here's the other thing. In this instance, on this foundation, I made a major mistake when I excavated this out, and I put a big giant pile of sand right there, which I could have moved by hand. I didn't have a piece of equipment here to do it. I didn't want to do that. I have a batten board here, and I couldn't pull a line through there without doing a ton of trenching through that pile by hand. So here's what I did. I set my back line up. That was my benchmark. I did not move that line. That's the point that I knew I was going to maintain, and that was my constant. Measure from here over to here on both ends. I set that at 48 feet parallel off of that line. I knew it's perfectly parallel, 48 feet off, right? And then I set this string here and that string there, and I make them perfectly 50 feet parallel with each other, and I get it square. I actually got that string square with the front and back lines, and then I set this one parallel with that string, which in theory that one should then also be square. But to confirm that, typically I would do a double diagonal, make sure that those two dimensions are the exact same with each other, but I couldn't because I got a pile here. So I took and I pulled a diagonal from that corner to that corner and made sure that it was 69 foot 3 3/4 of an inch, which is what the calculator says it's supposed to be. And if that dimension from that corner to that corner is correct, and these four lines are parallel with each other, you know that building is square. So there's no point in really doing the second diagonal unless you really feel like it. It just, math does not lie. So that's what I love about this calculator, is the fact that you can calculate feet and inches, and it gives it to you in feet and inches, no decimal points, no conversions. It does the conversion for you. And doing stuff like squaring up a foundation like that is fantastic. It is also great for calculating rafters. So unlike this house, this is not the prints for this project. I just pulled these out because I had them in my truck, and I thought I would just use it as an example. But on this house here, it was a conventionally framed house. We used I-joist rafters. I had to calculate what length of rafter we were going to need. So this building is 30 foot wide. So actually, I don't know if I can do this one-handed here. A section cut might be better. See if I can find a section cut to demonstrate what I'm talking about. Here we are. Here's a section. We're 30 foot wide, correct? And it's a 12-12 pitch. So that one's really simple. 12-12 is nothing difficult to figure out on that one. So if we're 30 foot wide, my span is 15 feet, half of that. So we got 15 feet run. We can call it run or span, same thing. And then we know my rise, being that it's a 12-12, is also 15 feet. So we'll go 15 feet rise. Give me the diagonal. It's 21 feet 2 9/16 inches would be my length of rafter. Plus I got to add for tail and stuff like that. But that is a good way to figure out what your rafter length is going to be. Hip and valley. There's no hip or valley on this one or the project I'm currently working on. But if you really want to know, let's say we got a I'm actually not the best one to use this because I usually figure it out on you know, I'm gonna have to do another tutorial on the hip and valley part. I've actually done it, but it's been a really long time, so sorry about that. But the calculator does come with a little cheat sheet on the cover that covers it here, so you can get your linear entry and conversion, square entry and conversion, which I just demonstrated to you, in your cubic entry. Cubic entry, that's the one I use a lot. So on this foundation here, I had 196 lineal feet of footing, right? So 196 feet times 18-inch wide footing times my average depth ended up being about 9 inches. 9 inches gives me 8.16 or 8.17 cubic yards of concrete. So that's a nice feature there as well. And then let's say I got something that's 156 inches. I want to know what that is in feet. Just hit feet. It's 13 feet. Or I got 13 feet. Hit inch. It's 156 inches. So super simple stuff like that. If you need more detailed, in-depth calculations, this is certainly capable of that as well. If I can get it out of there. And it's got a little pocket reference guide that stores in the calculator itself. And I will actually go through that and figure out and detail out the hip and jack rafter calculations for those of you that want to know that, and show you how you can calculate those on this calculator as well. Because actually I've got a hip roof project coming up, and so I need to refresh my memory on that as well. And then just doing estimating, for example, I got this building, for example, which is 50 by 48. I know I'm going to do frame at 24 on center. So we got 196 lineal feet. Divided by, actually that's really easy, 24 is really easy. Let's say it's 16 inches on center. So divide by 16 inch. I know I need 147 studs. Plus one for 0. Plus you got to add in your cripples and trimmers and stuff for doors and windows, and your California corners, or however you're going to frame your corners, stuff like that. So, but for your simple straight runs without doors, windows, and stuff like that, you know you need 147 studs. That gets you a good starting point. Anyway, long of the short of it is, or the short of the long of it is, Construction Master 5 by Calculated Industries. For any carpenter, builder, dirt work guy, someone in the construction trades, highly recommend this calculator. 40 bucks at Home Depot, available on Amazon, probably eBay and other sources as well. I'm not getting promoted to, I'm not getting paid to promote this product. This is just something I've used, love, and thought that you guys might like to see it. It's my cheat for not being so good at calculus and trigonometry. Anyhow, thank you guys. If you like this information, if you like my other videos, want to see more of this project or other future upcoming projects, subscribe. Please hit the bell so you get notified. Hit the thumbs up and the like button, and that will inspire me to continue making more videos. I got a ton of ideas. Not all of them are construction related, even though that is what I do. I like trucks. Okay, I like trucks. I like hunting. I like fishing, camping, off-roading, and I'm going to throw all of that at you as it comes around. Just guy stuff, random guy stuff. That's what I'm about, and we'll see you next time. Thanks for watching.